Imagine being positioned for an interstellar shocker. A group of scientists believe that Betelgeuse, the mesmerizing red supergiant star adorning Orion's shoulder, has already exploded. That's right, you heard it correctly. Within the next decade or a few hundred years, its awe-inspiring supernova will illuminate the night sky. But how did researchers arrive at this conclusion? Should we be worried? And can the James Webb Space Telescope capture the remnants of this colossal event? Let's dive into the latest details about one of the most recognizable stars in the night sky. In the northern hemisphere, especially during winter, Betelgeuse stands out as a red supergiant star. It's one of the brightest stars visible to the naked eye, radiating a reddish-orange glow, making it typically the 10th brightest star in the sky. However, Betelgeuse is far from an ordinary star due to its massive size and peculiar behavior. If we replaced our Sun with Betelgeuse, its size would extend all the way to the asteroid belt, and its mass is approximately 10 to 20 times that of the Sun. Though Betelgeuse is a young star, only 8 to 10 million years old, it's burning through its nuclear fuel rapidly and is expected to go supernova relatively soon in cosmic terms. The fascinating story of Betelgeuse's behavior goes back to ancient times. Around the 2nd century BC, Chinese astronomers noted that Betelgeuse appeared yellow. Fast forward to the 2nd century AD, and the Greek astronomer Ptolemy described it as reddish, similar to how it looks today. Medieval astronomers in the Middle East also observed a similar reddish hue. These records suggest that Betelgeuse may have undergone a dramatic color change over just a few hundred years, likely transitioning from a yellow supergiant to the red supergiant we see today. Betelgeuse's variability in brightness has long fascinated astronomers. In December 2019, its brightness unexpectedly plummeted, a phenomenon that was clearly visible to the naked eye. By mid-2020, its brightness had recovered, but not without generating considerable speculation. One theory was that overlapping cycles in Betelgeuse's variability caused the deep dimming, but observations from the Hubble Space Telescope revealed a different story. Betelgeuse had ejected a massive amount of material, forming a giant dust cloud that blocked much of its light from our vantage point on Earth. This event was astonishing. Betelgeuse, once among the 10 brightest stars, dimmed so much that it dropped to less than the 20th brightest star in the sky. The dramatic change caught everyone's attention, particularly in comparison to the nearby star Aldebaran, which remained steady at 14th brightest. Though Betelgeuse eventually brightened again, its strange behavior didn't stop there. Recently, Betelgeuse's brightness has surged, exceeding its usual luminosity by an astonishing 50%. This unexpected increase has puzzled astronomers. While the dimming could have been caused by dust clouds or cyclical patterns, a significant surge in brightness suggests something much more unusual might be happening. One prominent theory is that Betelgeuse is nearing its supernova stage. While conservative estimates suggest the star is still about 100,000 years away from exploding, new research proposes that Betelgeuse may have already gone supernova, and we could witness its remnants in the next 10 years, or a few hundred years. A recent paper by Hideyuki Seo and colleagues from Tohoku University in Japan supports this bold claim, suggesting that Betelgeuse's recent behavior could be the aftermath of a supernova explosion. Through a detailed analysis of Betelgeuse's variability patterns, the researchers identified 4 distinct cycles, with the longest one being a key indicator that the star may be in its final phase of nuclear fusion, burning carbon, a sign of impending supernova. Despite conflicting interpretations about Betelgeuse's future, many astronomers believe the star is a prime candidate for the next supernova in our galaxy. If Betelgeuse has indeed exploded, it could be one of the most spectacular celestial events we will ever witness. However, don't start planning a sky-watching party just yet. Though we know Betelgeuse is acting unpredictably, it has recently slipped behind the Sun and won't be visible again until August. Betelgeuse's sheer size and relatively close distance of about 650 light-years from Earth allow us to observe it in more detail than most other stars. Unlike most stars which appear as simple points of light, Betelgeuse is close enough for astronomers to capture images of its disk, revealing fascinating variations in its brightness. This provides a unique opportunity to monitor the star and gather more data, including photographs of its ongoing changes. If Betelgeuse has indeed gone supernova, We are in for a cosmic light show like no other. But don't worry, it's perfectly safe for us on Earth. Even though Betelgeuse's explosion would be incredibly bright, it is far enough away that its radiation wouldn't harm us. Instead, we would be treated to a stunning display in the night sky, with Betelgeuse shining as bright as a full moon for several weeks or even months. While scientists continue to study the star's strange behavior, our planet, all we can do now is wait and keep our eyes on the sky. The moon will still dominate by a large margin, and the sun, of course, will continue to cast its own shadows at night and remain visible during the day for about a year. The interesting thing is that this supernova would be visible at night for quite some time before eventually fading. There may be a brief period where it regains some of its former brightness, but it will ultimately dim until the once bright star in the Orion constellation completely vanishes. Although this supernova poses no direct threat to us, it could cause some confusion in nature. Certain animals rely on starlight for navigation, and the extra bright light casting unfamiliar shadows might throw them off course. But that's not the only impact. Astronomy itself would face challenges. Observing the night sky when the moon is shining brightly can already be tricky, and a supernova of this brightness would make things even more difficult. Many telescopes would likely focus on capturing the supernova's glory, even if it meant adjusting their observations. Interestingly, there would be some warning signs before the main event, such as the detection of neutrinos and gravitational waves from the star. But the big question remains. Has Betelgeuse, the star in question, already gone supernova? We might need to wait for the James Webb Space Telescope to confirm whether we're seeing the remnants of the explosion. As for when Betelgeuse will explode, it's uncertain. It could happen next week, next year, or even in 100,000 years, which, in astronomical terms, is practically right now. And we must remember that the light we see from this star is already very old. If it exploded long ago, we wouldn't even know yet. What do you think? Could Betelgeuse have already exploded? Or is it simply undergoing some strange changes? Let us know your thoughts. The James Webb Space Telescope is undoubtedly the best tool for studying these events, and we shouldn't have to wait long before it sheds more light on this mystery. Understanding Betelgeuse's behavior and its implications for stellar evolution involves a complex strategy, combining observational astronomy, theoretical modeling, and historical context. This star, known for its variability and massive size, offers a fascinating opportunity for astronomers to study the life cycle of giant stars and the phenomena leading up to supernovae. It's important to grasp the significance of supernovae within the broader context of stellar evolution. A supernova is not just a dramatic event. It plays a crucial role in dispersing heavy elements throughout the universe. These elements, forged in the cores of massive stars, become part of the interstellar medium, contributing to the formation of new stars and planetary systems. Studying Betelgeuse and similar stars helps astronomers understand the chemical evolution of the galaxy and the processes driving stellar development. If Betelgeuse is approaching or in the midst of a supernova, it would mark a critical moment in the star's life cycle. Scientists are particularly interested in the mechanisms governing the transition from the final stages of a massive star's life to its explosive end. Current models suggest that as stars like Betelgeuse near the end of their lives, they undergo a series of complex processes, including core collapse and the ejection of their outer layers. These stages are characterized by significant mass loss, which can affect the star's brightness and variability. By observing Betelgeuse's changes, researchers can gain insights into these processes and refine their models of stellar evolution. Historical records of Betelgeuse's brightness fluctuations and documented color changes provide valuable clues about its past states. Although ancient astronomers' observations were limited by the technology of their time, they offer a baseline for comparing current data. The transition from a yellowish hue to a reddish-orange tint over centuries could reflect the star's internal changes and its progression toward a supernova. This historical perspective enhances our understanding of how massive stars evolve and how their life cycles impact their surroundings. The potential for Betelgeuse to become a supernova also intersects with our broader understanding of cosmic events. For instance, studying supernovae helps astronomers examine the conditions leading to different types of explosions, such as Type 1 and Type 2 supernovae. Type 1 supernovae typically result from nuclear explosions in binary star systems, while Type II supernovae, like the one expected from Betelgeuse, arise from the core collapse of massive stars. Understanding the differences between these events can help researchers unravel the history of our universe and the frequency of such occurrences. Observational challenges, such as Betelgeuse's current position behind the Sun, highlight the complexities involved in studying such dynamic celestial objects. However, astronomers use various methods to monitor stars that are temporarily obscured. For example, space-based observatories and specialized telescopes are employed to track the star's light curves and analyze its spectral data. These techniques provide crucial information about the star's composition, temperature, and potential for a supernova. Additionally, theoretical approaches, including computational models, play a key role in predicting and understanding supernova events. Scientists create simulations that integrate current observations, historical data, and theoretical physics to estimate how a star like Betelgeuse might behave. These models help predict the timing and characteristics of the supernova, offering insights into what observers might expect and how the explosion will affect the surrounding space. The implications of a supernova from Betelgeuse extend beyond the realm of astronomy. For example, a supernova of this magnitude would enhance our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no threat to our planet, studying supernovae improves our knowledge of cosmic rays and their interactions with Earth's atmosphere. This information is vital for understanding space weather and its potential impacts on satellite operations. The possible discovery of Betelgeuse's supernova remains a source of excitement and interest within the scientific community. Such an event would not only advance our understanding of stellar life cycles, but also capture the public's imagination. The dramatic visual spectacle of a supernova, visible for months or even years, would undoubtedly inspire a new generation of astronomers and space enthusiasts. Public interest in cosmic events often fuels educational efforts and promotes scientific literacy, underscoring the importance of continued investment in space research and exploration. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. Ongoing observations and theoretical work surrounding the star contribute to a broader perception of the universe's workings. As we await further data from the James Webb Space Telescope and other observatories, the study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is approaching that dramatic event, its story highlights the ever-evolving nature of our exploration of the universe and the relentless quest to uncover its mysteries.